Hello ladies and gentlemen, and today we are going to solve dynamic programming problem called arithmetic slices from Leetcode. So let's get started. Now the problem says that a sequence of numbers called arithmetic if it consists of at least 3 elements. So if it consists of at least 3 elements, and if the difference between any 2 consecutive elements is the same. So if the difference between any consecutive, so it could be like 3, 5 difference is 2, 1, 3 is 3, 1, 3 is difference is 2, so that means 1, 3, 5 is a sequence, arithmetic sequence, because the difference between 1 and 3 and 3 and 5 is the same, or 1, 3, 5, 7 is the same, is another arithmetic sequence. So, and these are, so, and if the difference, for example, so here's the examples. So 7, 7, 7. The following sequence is not arithmetic. So this one is not, because 1, 1 is not at least, it says at least 3. It would work if it had extra 1 in here. So the difference between 1 and 2 and 1, 1 is not the same, so they're not. So same here. Now in this problem it's saying that your function should return the number of arithmetic slices in the array A. So the slice is defined as the P and Q, where P is greater or equal to 0, and then Q is greater than P and less than the entire length of the array. So what does it mean? It basically means like all the subarrays that are arithmetic should basically return the number of subarrays are arithmetic. So for example, 1, 2, 3, 4, one arithmetic slice is 1, 2, 3, the second one is 1, 2, 3, 4, the third one would be 2, 3, 4. So there's in total 3 arithmetic slices. Now let's get straight into the solution. We are trying to solve it using a dynamic bottom-up programming approach, and let's get started. So for this problem we will be using a bottom-up dynamic programming approach, and let's try to think how we could come up with a solution. So in dynamic programming you usually use 2D or 1D array, especially in bottom-up dynamic programming, while in top-down approach you usually use memorization, like a hash, something like that. So over here, what we are trying to do is basically to come up with all the different combinations of arithmetic slices. So one thing could be like, so there the rule is that the length, the least length of the arithmetic slice could be 3. So that's why 1 by itself or 1, 2 cannot be an arithmetic slice. So he's saying that if we have 1, 2, and 3, that means this is 1 arithmetic slice, because the difference between them is the same. So there's 1 incrementing by 1, or over here it's incrementing by 2. So this is another one. So 4, 6, 8 would be another arithmetic slice. So or if you had 4 here, that would make 1 arithmetic slice, 1, 2, 3, and it's the same difference, and the least length should be 3. So the 1, 2, 3, 4, that's another one, because they're all the same, and 2, 3, and 4. So as you see, there are 3 possible combinations. So now, how do we come up with a solution to this? In bottom-up, usually you are trying to come up with a solution to smaller inputs. So, and then use that solution from smaller inputs, store that somewhere in a 1D or 2D array, and then under so let's say if you know the solution for array I the least length of arithmetic slice we could have should be 3, right? So at 1 and 2, that's saying that there are number of arithmetic slices are basically, if we only had 1, the number of arithmetic slices would be 0. If we had 2, it will also be 0. Now what if we had 3? Now the length is 3 right now. So that means that since the difference is the same, we have to check if 3 minus 2 is the same as 2 minus 1. If the difference is the same, then that means 1 to 3 is only one arithmetic slice. So we just say 1, right? But now let's look at 4 here. If we add 4, that means there will be 1 to 3, which is one arithmetic slice, and 2, 3, and 4, and 1, 2, 3, and 4. So 1, 2, 3, and 4, 1, 2, 3, and 2, 3, 4, right? So we know that from the previous solution, we already know that 1, 2, 3 gave us one combination. And adding 4 to this one would also give us one more combination, right? So you could use this idea, like if 1, 2, and 3 gave you one combination, and if you added 4 to this, that would still give you one combination. So to come up with a solution for 4, we use a previous solution, which is for 3. So we'll use, let's say our array is called dp, and we use the same solution. So dp, and this is the i's position. So we are at i's position, so we're gonna say I minus 1. That would give us 1, right? Because the solution for 3 was 1. Now it's 1. Now so it's 1, 2, 3, 4 is one combination. But we also have 2, 3, and 4. That's another combination. So in this case, since we also have 2, 3, and 4, then we just add plus 1. So now we'll use this to come up with a solution to all the upcoming inputs. So if we add 4 here, now so dpi minus 1 plus 1 for 4 would be, so dpi minus 1 would get us here 1 plus 1, that would give us 2. So 2, 3, and 4, 1, 2, 3, and 4. So that was 2 combinations, 1, 2, 3, and 4, and 2, 3, and 4. We don't care about 1, 2, 3 because it already stored at 3. So to come up with the entire, to like come up with all the possible combinations, we usually store them here, and then at the end we just sum everything in the array. So currently there are 3, but at 4, that means there's 1 and 2, and we added, and there are 3 different combinations. So 1, 2, 3, 2, 3, 4, and 1, 2, 3 itself. 1, 2, 3, 1, 2, 3, 4, 2, 3, 4. So now at 5, use the same concept, dp I minus 1 plus 1, because I minus 1 give us 2, 2 plus 1, because we are, it could be 2, 3, 4, 5. So now it's going to give us 3. So it's the same concept, and that's how you come up with the bottom-up dynamic programming approach to this problem. And so just remember the way you would calculate the next. So like dp I minus 1 plus 1. That would work even for 1 and 2, because if there are 0 and 0, and you try and come up with a solution to 3, so that dp I minus 1 would give you 0, plus 1 would give you 1, so that would be 1 here. And now we try and come up with a 4, and dp I minus 1 give you 1, still be 1, right? It will still be 1 combination. However, to take care of 2, 3, and 4, we just have to add +1 to it. Just have to. It's a little tricky. Just add +1 to it, then the problem is solved. And now to come up with a solution to 6. So every time we are. So to come up with a solution with 6 right now. Every time you're using this, you first have to check, as we said at the beginning, the difference between the current difference. So if we are trying to calculate it for 6, then we have to find the difference between 4 and 6, and then 3 and 4. So currently the difference between 4 and 6 is 2, and 3 and 4 is 1. So that means just put 0 here, it wouldn't work. It's not as arithmetic sequence. So now let's get straight into the code. And so here's the code for this problem. So what are we doing here? The first thing to do is to create a 1D array containing a number of elements in the array. So and all of them would be initialized to 0. So the array is basically contains a number of arithmetic slices at that index. So that's how we initialize it. And then for the for loop, we start from the second index. So, we start from a third index because the least length should be 3. So that's why we just skip the index 0 and 1. So once we have that, so let's say, let me just put 1, 2, 3, 4, 5, right? So if we have this, what we are doing here, we are at 3 right now, the I is at 3. So I'm taking AI basically means 3, because the index currently is at 2, so 2 is this index, and 2 minus, and over here I minus 1, which is 2 minus 1, would give us this index, which is 2, so 3 minus 2. What we are doing here, taking the difference of these two and comparing it with the difference of these, and that's why this part basically I minus 1, which is 2, minus I minus 2, which is 1. So it gives us 2 minus 1. So 2 minus 1 is 1, and 3 minus 2 is 1. So since the difference is the same, that means this is a arithmetic sequence. So that's why that's why we say dpi equals, dp is our 2D array, 1D array, and then we are updating at that position the number of combinations, like over here. So at this position we're saying it's 1, and we are using this dpi minus 1 plus 1. So like you see, dpi minus 1 plus 1. Else, if it's not, the difference is not equal, then that would be 0. So at the end you just return the sum. And the code is pretty simple, and hope that makes it clear. And if you're still confused about it, just comment below this video and I'll try my best to answer. So if I say submit it, great. So it actually bids 100% of the Python submissions. See you guys later. See you in the next video.